We have the function f of x, which is the tangent hyperbolic of x, and we would like to compute this integral. It's a really interesting integral to compute. So this is the integral from 0 to 1 tangent hyperbolic of x dx. Of course, we know by definition that the tangent hyperbolic of x is sine hyperbolic of x over cos hyperbolic of x dx. Now let's pay attention that the numerator is the derivative of the denominator. So this is cos hyperbolic x prime over cos hyperbolic x dx. Prime means that we have the derivative of this function. The derivative of this function gives sine hyperbolic of x. So let's see. Let's see how we can proceed with this integral. We have the integral from 0 to 1. Now let's have a look at this function. We have ln of g of x, okay? And we take the derivative with respect to x. So we have 1 over g of x times g prime of x. So if you have a close look there, we have a similar thing. So we have natural logarithm of cos hyperbolic x, and this is prime dx. So if we differentiate this function, we get 1 over cos hyperbolic of x times cos hyperbolic of x prime, which is the sine hyperbolic of x. So from here we go to here, and this is natural logarithm of cos hyperbolic of 1 minus natural logarithm of cos hyperbolic of 0. So this is natural logarithm of cos hyperbolic of 1 minus cos hyperbolic of 0 equals 1. So the natural logarithm of 1 is 0. So this is natural logarithm of cos hyperbolic of 1. So my integral is natural logarithm of cos hyperbolic of 1. So I wanted to compute this integral. By definition, the tan hyperbolic is the ratio of sine hyperbolic over cos hyperbolic. I write this integral in the numerator, the derivative of cos hyperbolic, and then here is a very interesting result, because from here I go to here, that the natural logarithm of cos hyperbolic of x prime gives this result and this result. So finally I obtain the desired function, and I have to evaluate, of course, this function. The bounds of integration, the lower bound is 0 and the upper bound is 1, so this term vanishes because the cos hyperbolic of 0 equals 1 and the natural logarithm of 1 is 0, and I end up only with the natural logarithm of cos hyperbolic 1, which gives this result for my integral.